Regarding the microbiological analysis, here we can see that the bacteria are more abundant compared to yeast and Filamentous fungi. In fact, the median value of TBC was about 7 log CFU per gram. Instead, the median value for yeast and Filamentous fungi was about 6 and 4 CFU per gram respectively. The Enterobacteriaceae group was dominant compared lactic acid bacteria. The results obtained in this preliminary work are, in particular regarding the TBC, are similar with those reported in other studies. On the contrary, yeast and Filamentous fungi resulted more variable compared with those reported in literature. Regarding the effect of the cultivar and geographical area on the microbiota of barley seeds, we can see, looking at the panel A, that cultivar did not affect the microbial distribution on the barley seeds. On the contrary, some difference were observed in the panel B. In particular, we can see that the TBC abundance was higher in Umbria, in the sample from Umbria region, compared to those of Lazio, Apulia, and Molise region. In conclusion, bacteria in barley seeds are more abundant compared to yeast and Filamentous fungi. The Enterobacteriaceae are prevalent compared to lactic acid bacteria, and cultivars do not seem to have a major impact on the barley microbiota. On the contrary, geographical area has a strong impact on the total bacteria count, but no difference were observed for yeast and Filamentous fungi. Moreover, TBC abundance is positively associated with colder area and with low evapotranspiration. The study, although preliminary and in process of further analysis, suggests the importance of agroclimatic condition on the composition barley microbiota in Italian areas. And several activities are ongoing and planned for the future, including lactic acid bacteria isolation and characterization, metagenomic analysis, the evaluation of other agroclimatic indices, and correlation study between barley microbiota and agroclimatic indices. Thanks for your attention.
Any questions? Any questions to Dr. Gianfranco? Thank you, sir. Thank you. Yeah. Any questions? Thank you, sir. Thank you for your participation. You will be getting the participation certificate within 2 to 3 days. A soft copy of booklet and certificate. We truly value your presentation and support for this conference. Thank you for joining and for your attention. Thank you. Have a nice day.
Thank you.
Now, I would like to request Dr. Mariam Mohammed Al Ghazi, food science specialist, Sultan Wabs, University Oman, to start with speaker presentation.
It's clear?
Yes, ma'am, it's visible.
Okay. First of all, good morning to all, but it's good afternoon from our country, and it's Ramadan time. Thanks for to give me a chance to participate in this conference. Actually, this is the third times I participate in the Conference on Food Safety Regular Measures. And this is my pleasure that to be at the third time for participant. My presentation, it will be about the edible coating, which is a kind of preservation method that could help to extend the shelf life of food product. So I will go through all these points which I listed in the slide. As we know that the food products, we can use the preservation method to extend the shelf life, and we can use the novel method, which is the edible coating, which functionality of edible coating. What does meaning of edible coating? Edible coating that could help is a material that can be used as a coating of food product. It give us clothing by using different type of material. If I'm going to talk about the historical or the previous historical between the edible film and edible coating, for edible film on 1967, it's still not developed, but it needs a little commercial use. So for example, in edible film in Japan, for example, they use soybean for edible film to extend their shelf life, and also the meat. What about the edible coating? Sorry. For edible coating, we use also the citrus for fruit to extend the shelf life of fruit and vegetable. I know that most of the people, they know that when you go to the market or to supermarket, you will see some of the food product is glossy. But are you sure that we are using for edible coating is edible or no? Okay. So this is what is shown in the slide, the food, how do we do coating and how we do flame. And they say that coating is better than flame. Why? Because coating is work as antimicrobial. So how we create the characteristic of edible coating? So that means the characteristic, the properties of edible coating is very nice. It's anti-static and it's antioxidant also, anti-floating and anti-protein, also anti-foaming. So where is the novelty? Because I start with the novel. I said functional novel method. It is in which it is novel. I want to make sure it's helped to coating the process and method development, future coating, develop the product in a good way, applying in the industry, and they control the releasing of food product. Okay. Here, the questions as a novel edible coating for fresh fruit. I know that you will shock. Yes, most of the fish and fish product they throw the skin, the surface skin of the seafood, and they do not use it. You know, this is very valuable. They use it as edible coating. They take the skin from the Krishnas, they drying, and they make it as a powder. So it's make it in the fruit as edible coating, as is give us the glossy. Do you imagine? So in the historical, how they use it and how they apply it, as it's shown in the machine, there is a spray machine. It's help immediately. You put the coating, which is made by yourself from different materials, and you put it in the machine, and it help the machine. It help us how they distribute the border or the coating that have been made by ourselves in the fruit. Okay. Actually, I know that most of the participants or the audience of my presentation, they will ask how we can make this coating. First of all, we have to wait the food sample. For example, apples, I gave apples. We have to wash the apples. Why we have to wash the apples? To avoid any contaminated is available, any dust in the fruit, because if you are coming, because our goal is to preserve or to extend the shelf life of food product. And so I use the edible coating. In order to make sure that edible coating that I applied in food product or in the apples, it's going well. So I have from A to Z to make sure that I did the coating in proper way. So it's necessary to clean the apples from outside. We have to dry the apples and then store the desirable apples, coating the apples by spray method, dry the coating apples, storing the desirable coating apples, and then packaging the coating apples. Then it will be easily to distribute it in the market. And make sure in the books, you have to put the label in that I use edible coating, and make sure this edible coating is edible, could not affect the health of people. So how's the thickness? Why I'm talking about the thickness of edible coating? Because the how the thickness in the food product could affect the growth of microorganism, or the growth of or rancidity, or the chemical poisoning, and so on. So there is high thickness, medium thickness, and low thickness. There is a previous studies, so I'm giving to you the previous studies. What is show that consumer perception and application of edible coating in fresh fruit and vegetable. See how the people previously they use it. Okay, what is the type of edible coating? There is a polysaccharide edible coating, and also there is a study they use the gum arabic for coating for dried mango slice. You know, the gum arabic in our country, Oman, we use it a lot, and it's very famous in Salalah. So we take it, we grind it, we make it as a powder, and they soaking in the water, warm water, and then we have to apply it in the dry mango slice to extend the shelf life of mango. And then the another type of edible coating is protein. Do you imagine? And then the lid, as it's shown in the slide. And then the plasticizer. I know some of the questions come in your mind. What is the plasticizer? This plasticizer, I noticed that some of the hotels, they use it in their food product, and they use it in the food industry to avoid the viscosity of the food product and to make the food is more soft. And there is previous studies is using the coating the egg by the catecholamines, and I told you about the freshness of the seafood. And another type is emulsifier. We're using sunflower oil and the TV. The gum arabic, how we can use it. The gum arabic with specific weight. We take the amount of gum arabic. We have to grinding to get powder, and then we add into the water with the specific volume, and then we get the solution. After that, we have to adding additives like a sugar or antimicrobial to help the coating to be in a good characteristic, and it is in a good properties. And then we heating to get the coating. Okay, how we can use the cushions if the naval edible coating? We get the shelf of waste, the shrimp waste, and we grinding and we make it as a powder. We mix it with the hot water, and then we get the coating. Okay. This is a type of historical or the previous studies. So because when I talk about edible coating, I have to support my talking or my presentations or the information that I got it by the studies. So the effect of edible coating, the shelf life and quality of potato. Actually, studying effect of edible coating of Arabic gum. What I saw that Arabic gum is repeating again and again. Why? Because it is pure and we can be easily to prepare it. And olive oil and the storage life maintain quality of post-harvest with lemon. By the way, they use olive oil, and the olive oil is very essential and is very important for our health. Okay, also in the Kuala Lumpur, they use it in UKM University about the coating. So what is the advantages of the edible coatings? Improve the color, acid sugars, reduce the weight loss, maintains quality during distribution, reduction of storage condition also, improve the consumer demand, and extension of the shelf life, which is the most important point that I spoke in previously when I start my presentation, and reduction of artificial packaging. What is the limitation? There is a limitation, but we have to take care about this limitation, why and how. Let's start with the how. The limitation, before I apply the coating, for example, in the apple that it show in the slide, we make sure that the apple that I use it is cleanable. There is no mold, there is no yeast show, and there is no desirable physical breaking, and we have to clean it and dry it properly. Then I have to edible. So this is a kind of limitation. If we do not do, the oxidation it will be heaven, it will be bad of flowers and the formation of anaerobic condition. So that will let an aerobic bacteria to catch the fruit and to damage it and to spoil it also. Okay, how is the coating? How we apply the coating? Previously, I said they can be using as spray and can be using also the coating, using the brush also, and others way by sucking just the water and the let of the coating, to drop in the food product, and will be distributed easily within each type of food product. Or previously, we can use it physically, right? But we can use machine, but make sure that machine is work properly and it's clean before and after opening. Why? Because the hygiene is very essential. And I told you, I repeat it again, the hygiene is very important. The hazard, that critical control point is very essential. If we are not care about this kind of point, it will be damaged. This is a kind of machine. So how we can application? We can use it in food product, can use it in drug and tablet and the house items. And also we can use it in the cosmetic. Therefore, when I talk about my presentation, I relate it to my university and also to my top one, spa. We can use the cosmetic, some of the cosmetic, because some of the cosmetic, we have tablet, and this inside of that tablet, there is a drop liquid. We can use it in the hair treatment, and we can use it in the skin treatment. Therefore, we use coating to some of the cosmetic product. So this is the action, how they apply the edible coating. You will see that the oxygen, the dioxygen going inside and outside. Dioxide carbon. So how it's affect the environment, the edible coating, in the environment. Edible coating material has positive effect. No radiation exists. Many of coating material and operation are high in cost. Standards, they are capital, energy, and operating cost. In conclusion, in general, the edible coating is still in development till now. Several processing application parameters bring the coating. Various of food product could be coated. The cost of edible coating depends on the type of material and the coating and how you apply it, how you manage it, how make sure that the one that you did in a proper way, step by step, critical control points, and you have to follow all these things. The recommendations: safety of food products should be maintained. As I told you previously, harmless coating materials, proper preparation rules approved by Food Drug Administration. The food should be free from any abrasions. Proper storage of coated of food product. This is my reference that I get information from it. This is a video. Exactly. Yeah, exactly. That's all about my presentation. I hope you like it and you like all the information that I shared. If you have questions, I'm ready to answer. Thank you very much.
Any questions? Any questions to Dr. Mariam? Thank you, ma'am. Thank you for your participation. You will be getting the participation certificate within 2 to 3 days.
Thank you very much. Thank you.
And a soft copy of booklet and certificate.
Inshallah. Thank you very much.
Now, I would like to request Serena Santocola, University of Moilsi, Campobasso, Italy, to start with speaker presentation.
Good morning.
Good morning, ma'am.
Can you see my screen?
Yes, ma'am. It's visible.
Oh, okay. Okay. So, good morning, everyone. Let's start to define microplastics. So, microplastics are particles with different shapes, such as films, fibers, beads, pellets, and fragments. And these particles are classified into primary microplastics, which may be produced directly in micro-sized dimensions for domestic or industrial uses, and secondary microplastics that may derive from the fragmentation of larger plastic objects and synthetic textile items. Among the different shapes of microplastics in the environment, microfibers are predominant, and as you can see in the feature. And more in general, microfiber pollution includes both synthetic and natural artificial particles. But at the moment, the available studies are only focused on synthetic microfibers. Most of the microfibers in the environment are released from the textile industry, and the rapid turnover of the fast fashion has been
Your PPT is not visible.
Sorry?
Your PPT is not visible.
Okay, okay. So, okay. I try to share another time my PPT. So, okay. Now?
Yes, ma'am, it's visible.
Okay, okay, okay. So, and the rapid turnover of the fast fashion has been a dominant factor in the production and waste of textile items. And in addition, a high number of microfibers may be released also during domestic and industrial laundry processes. And in addition to marine pollution, these particles have also been detected in the soil from agriculture mulch film and waste disposal, with potential accumulation also in plants and transfer along the terrestrial food chain. So starting from marine pollution, the wide distribution of microfibers may result in the exposure in marine biota, and several studies have detected these particles in the gastrointestinal tract of farmed and wild fish species at levels higher than those detected for other microplastics, as you can see the data in the table. And in this context, mussels have been identified as potential bioindicators to detect microfiber pollution in the sea and the oceans, considering the positive correlation between the level of these particles in the water and their tissues, the wide distribution and the commercial relevance. According to the available data, farmed mussels may contain more microfibers than wild specimens, since they are often cultured in coastal areas and they grow on polypropylene lines. But the depuration that mussels may undergo before sale may help to reduce the quantity of filtered microfibers. So the exposure to microplastics and microfibers in marine biota may result in several health issues, such as the blockage of the gastrointestinal tract, low absorption of nutrients, and disruption of endocrine system, and several body functions, including reproduction, with consequences for biodiversity conservation nutrition and including food security. In addition, microfibers may carry potentially harmful chemicals such as additive or toxic compounds that may be released in the tissues of animals ingesting these particles, leading also to human exposure through the consumption of contaminated seafood. In this context, we tried to assess the extent of microfiber exposure in commercial fish species collected from fish markets located in South Italy by applying a multi-species approach. Mussels, anchovies, red mullet, and European hakes were selected because considering their different habitat and feeding strategies and their economic relevance. The gastrointestinal tract of each fish and the soft tissues of mussels were removed and analyzed. The samples were digested in order to isolate microfibers that were firstly identified by applying a visual approach through the microscopical observation, followed by the chemical analysis by FTIR microscope. The results showed the occurrence of microfibers in 74% of mussel samples with a mean concentration of 14.5 microfibers per individual, while for the other fish species, the highest level of contamination were detected in the band.
Kindly change your. It's still stuck in the third slide.
Okay, sorry. I don't know why, but I share another time my presentation.
Okay.
Okay. Now?
Yes, ma'am.
Okay, sorry. While for the other fish species, the highest level of contamination were detected in the bentonic, red mullet, and European hakes. The chemical identification of isolated microfibers revealed the occurrence of a high number of natural artificial cellulosic microfibers. These particles have been identified as the most abundant marine debris, and therefore their occurrence in the gastrointestinal tract of fish may reflect their wide distribution. So I changed the slide. Can you see the new slide? I don't know. So, okay. The exposure.
No, the slide didn't change.
Okay. Ok, sorry. Vediamo se così va. Allora. Okay. Now, can you see the presentation?
Yes.
Okay. So, and the exposure to microfibers in humans can be lowered if the gastrointestinal tract is removed, because the gastrointestinal tract is the main location of these particles in fish. But small pelagic fish species such as anchovies may be consumed as a whole in different Italian dishes and may cause consumer exposure. In addition, mussels, which are usually eaten whole, could contribute to the number of ingested microfibers by humans. And moreover, there are also other food items that may be contaminated by microplastics. But at the moment, the data to make the evaluation of the estimated daily intake are lacking. in this context, it should be considered that in addition to environmental pollution, also industrial processes may contribute to food contamination. And in this context, a growing attention has been given to other food items such as milk, as you can see in the picture. And the available data revealed that among the isolated microplastics, microfibers are the most abundant. And in this case, the contamination may derive from textile items used during production and processing of milk, surrounding environment and handling. And as far as we know, there was no evidence on milk contamination and in Italy. And in this context, we tried to assess microfiber exposure by sampling 20 milk samples from 5 different brands. And the milk samples were available as pasteurized and ultra high temperature treated milk, and with different fat content. And the milk samples were analyzed, and the results revealed the occurrence of microfibers in 67.5% of the analyzed samples, with a mean concentration of 3.8 microfibers on 100 milliliters. The chemical identification of isolated microfibers revealed also in this case the prevalence of natural artificial cellulosic microfibers. Considering that the milk-blood barrier would prevent microfibers being transferred from blood into the milk, the contamination may derive from the production process, but considering the different types and polymers of microfibers identified in the current investigation, a conclusion about the possible contamination sources cannot be made. And both studies have revealed the prevalence of cellulosic microfibers both in marine and terrestrial ecosystems. And as regards the topic 1, the different habitat of fish may influence their exposure to microfibers, with bentonic fish being more exposed. While for the topic 2, the number of microfibers in milk samples tend to increase in processed milk, and the more complex the processing of milk, the more microfiber they contain. In this context, microfiber contamination should be investigated along the entire supply chain in order to identify the contamination sources and applying mitigation measures of contamination. In both cases, the available data are difficult to compare since the levels of contamination are highly variable among different studies, also due to the differences in the methodologies applied during the samples analysis. In fact, at the moment, the required quality control data to make a satisfying risk assessment are lacking, and the microfibers are frequently excluded, in particular natural artificial cellulosic microfibers from the studies because of methodological issues. Therefore, there is the need to standardize data collection method for the detection of microfibers in foodstuff, followed by exposure assessments for dietary intake. In conclusion, despite microfibers are the ubiquity of these particles in the environment, the research is still in its infancy, and there are many questions to be answered. First of all, the long-term exposure to microfibers in humans and animals should be considered as a research priority, and the future research needs to include also other food items and evaluate cooking and production methods in order to reduce the quantity of microfibers in foodstuff. In addition, research into environmentally friendly fabrics are needed in order to reduce the quantity of microfibers entering in the environment. And in this context, a One Health approach that recognizes the connection between the environmental health with that of animals and humans should be applied, considering that microfiber pollution may impact both aquatic and terrestrial ecosystems, resulting in risks also to food security and safety. So thanks for your attention.
Hello, ma'am.
Yes?
Is there any issue?
I don't know if there are any questions. I don't know.
Okay, ma'am. No, your PPT has been. Okay, any questions? Any questions to Serena? Thank you, ma'am. Thank you for your participation. You will be getting the participation certificate within 2 to 3 days.
Okay, thank you.
Now, I would like to request Mr. Brajesh Kumar, Indian Agriculture Research Institute, New Delhi, India, to start with his speaker presentation.
Thank you so much for this opportunity. Good morning, everyone. Do you like you see my presentation? Yes.
Yes, sir, it's visible.
Okay. Thank you so much. This is my presentation on partial application of nanofertilizers as a sustainable strategy for enhancing rice productivity in reclaimed sodic soil. My research talk highlighting how partial replacement of conventional fertilizers with nanofertilizers can boost rice yields in challenging sodic soils, reduce chemical inputs, and foster sustainable agriculture. It also underscores the collaborative efforts among leading Indian Agriculture Research Institute and industry partnership. So this slide addresses reactive nitrogen as a global environment concern, particularly focusing on urea overuse and the efficiency in nitrogen utilization, nitrogen use efficiency, region for urea overuse, pathway of nitrogen losses, consequence of low nitrogen use efficiency, need for innovative fertilizers. How this discriminate urea use leads to reactive nitrogen pollution, a global concern, and underscores the urgency of adopting smarter nitrogen management practices, nanofertilizers, precision application to protect the environment while ensuring sustainable crop production. In Indian scenario, in 2001, DST started Nanoscience and Technology Initiative. After 2007 to 2012, Nano Mission phase first. Then 2012 to 2017, Nano Mission phase 2 in India. These objectives of Nano Missions, launching of R&D programs, establishing centers of excellence, promoting institute industries linkage, facilitating entrepreneurship through establishment and business incubation. Urea facts for India and world, covering consumption trends, manufacturing capacity, greenhouse gas emission, subsidies, and nitrogen use efficiency. Urea consumption in India is 6.2 million metric ton in 1980 to 91, then increased 35.7 million metric ton in 2022 to 23. In the world, 75.40 million metric ton in 1990 to increase the 109.7 million metric ton in 2022. Urea manufacturing capacity in India, 31.3 million metric tons. In the world, 82.7 million metric tons in 2001-22. Dependency of urea in India, 80% reliance on urea among nitrogenous fertilizers. In world, 24 to 57% reliance, indicating very fertilizer huge partnership by region. So the India's protected fertilizer needed relative to its growing population and food grain requirements by 2025. India population is expected to reach 1.4 billion by 2025. To feed this population, India will need 335 million tons of food grains annually. The estimated NPK demand is 45 million metric ton per annum, up from the current consumption of 28 metric ton. Inverse relationship between rising food grain production and the decreasing fertilizer response ratio over time, as according to Chaudhary et al. 2015, declined from about 13.4 kg of grain per kg of fertilizer in 1972, 2.7 kg of grain per kg fertilizer used in 2015, implies diminishing returns on fertilizer inputs, indicating that more fertilizer is needed for smaller yield grain over the year. The orange bars The orange bars, this bar is show fertilizer application rate, kg per hectare that have risen significantly. So the transition of agriculture practices from conventional to nano fertilizer mediated agriculture, emphasizing how different approaches affect soil health, productivity, and sustainability. 4 types of agriculture illustrated: conventional agriculture, organic agriculture, bulk fertilizer mediated agriculture, nano fertilizer mediated agriculture. More nutrients, food, and high yield in nano fertilizers enhance soil biological health and microbial diversity, sustained nutrient release, and improved nutrient mobilization. Reduced demand for conventional fertilizers, minimizing environmental impacts. Way to improve nutrient use efficiency: split application of fertilizers, integrated nutrient management, polymer coating, slow release fertilizers, fertigation, diagnosis and recommendation integrated system, split application of nutrient management, and nano fertilizers. The environment pathway and negative impact of chemical fertilizers overuse, highlighting how low fertilizer use efficiency can harm ecosystems. Low use efficiency of chemical fertilizers results in significant nutrient loss and environment pollution. Water, air, and soil all become vulnerable to contamination and ecological imbalance. Improving fertilizer use efficiency through nanofertilizers and precision agriculture can help reduce these adverse effects, safeguarding soil health and water quality for sustainable farming. Nitrogen as a critical micronutrient for crops, detailing its sources, fixation pathway, and importance in plant growth. So nitrogen is a key drive of plant growth, yet inefficient use can lead to environmental issues and lower yields. Innovations like nanofertilizers and precision application can boost nitrogen use efficiency, supporting sustainable agriculture. This slide outlines various sustainable alternatives to conventional chemical fertilizers, each aimed to enhance soil health, improve nutrient use efficiency, and reduce environmental impact. A holistic nutrient management approach combining organic inputs, innovative fertilizers, and precision tools can reduce chemical fertilizer reliance, maintain soil fertility, and protect the environment. The concept of nanofertilizers, fertilizers engineered at the nano scale 1 to 10 nanometer to deliver nutrients more efficient and precisely to crops. Nanofertilizer present a cutting-edge approach to sustainable agriculture, offering high efficiency, lower environmental footprint, and improved crop performance. Nanofertilizers and highlights their unique properties and potential benefits for crop protection and soil health. Nanofertilizer are molecularly modified or synthesized at the nanoscale to improve soil fertility and enhance crop yield and quality. They can obtain macro and micronutrients, nitrogen, phosphorus, potash, zinc, iron, etc. in nanoformulations that target specific plant tissues, offering sustainable and homogeneous nutrient release. So nanofertilizers are next generation agriculture inputs that deliver nutrients precisely, improve crop yields, and support environmental stewardship, making them an alternative to traditional chemical fertilizers. Four main categories of nanofertilizers, emphasizing their unique modes of delivering nutrients and enhancing plant growth. Nanoformulation of micronutrients, nanoformulation of macronutrients, nutrients loaded nanomaterials, nano biofertilizers, nano carriers versus nanomaterials. Why nanofertilizers? Safety and eco-friendliness, precision agriculture, enhance plant health. By supplying balanced nutrient more efficiently, plant offer so improve growth, stress tolerance, and crop quality. Nanofertilizers, where micronutrient, macronutrient, nutrient loaded, or biofertilizers waste, offer a sustainable, high efficiency alternative to conventional fertilizers, minimizing waste and maximizing productivity. This slide outlines three primary approaches for manufacturing nanofertilizers, each differing in scale of production, particle size control, environmental impact, toxicity consideration. First is a physical approach. Second one is chemical approach. Third one is biological approach. Particle size and uniformity, chemical methods typically allow fiber control, while physical methods can produce larger volumes but with less uniformity. Environmental impact, biological synthesis is greener and less toxic but often slower and harder to scale. Application in agriculture, the chosen method impact cost, safety, and efficiency of nanofertilizers, influencing adoption by farmers and environmental sustainability. Conventional urea forms ranging from 1 mm to over 13 mm in diameter, with nanofertilizers 18 to 13 nanometer. Industry how dramatically reduced particle size changes nutrient diversity and efficiency. Why moving from millimeter scale fertilizers to nano scale formulations, farmers can achieve precision nutrient delivery, improve crop productivity, and significantly reduce environmental impact, showcasing the transformative potential of nanotechnology in agriculture. This slide explains how nanofertilizers act at different stages, from seed, root to foliar uptake, and how phosphorus and nitrogen behave once inside the plant. First one is seed root method of action. Second one is foliar method of action. Third one is distinction between phosphorus and nitrogen assimilation. Seed root application improves germination and root establishment, setting a strong foundation for the crop. Foliar application ensures quick nutrient uptake and targeted distribution within the plant. Nitrogen versus phosphorus dynamics. Phosphorus is easily distributed once absorbed, while nitrogen requires enzymatic pathway for incorporation into beetle plant compounds. By optimizing how nutrients are absorbed, transported, and utilized, nanofertilizers can boost crop performance, enhance nutrient use efficiency, and reduce environmental impact compared to conventional fertilizers. Nanofertilizer application in agriculture. Comprehensive look at how nanofertilizer are developed, formulated, and applied to crops, highlighting their benefits and sustainable agriculture. Why integrating nanofertilizers into in vitro and in vivo methods, farmers can optimize nutrient delivery, boost crop productivity, and minimize environmental damage, coupled with advanced formulations like nano emulsions, dendrimers, and liposomes. Nanofertilizers are poised to revolutionize sustainable agriculture for better yield, healthier crops, and a cleaner environment. The promising advantage of nanofertilizers with the practical and regulatory challenges that may limit their widespread adoption. Prospected of nanofertilizers, increased nutrient use efficiency, reduced application rates, improved stress tolerance, enhanced nutrient mobilization, high crop yield, better soil health, economic advantage. Constant and challenges, multiple relativity of nanoparticles, safety concerns, root toxicity, environmental impact, lack of guidance and regulations, industry hesitations. While nanofertilizers offering remarkable potential for boosting crop productivity, conserving resources, and improving soil health, robust safety assurement, clear guidance, and public acceptance are crucial. Overcoming these constant will determine how quickly and widely nanofertilizers can be integrated into mainstream agriculture. Nano-urea product and its role in promoting agriculture innovation and agriculture entrepreneurship. It outlines the key objectives of introducing nano-based nitrogen fertilizer into mainstream agriculture. Nano-urea exemplify agri-innovation by combining cutting-edge nanotechnology with practical farmer-friendly solutions. It aims to boost crop performance, reduce environmental impacts, and promote cost-effective farming paving the way of sustainable entrepreneurship driven agriculture. Technical specification of nano fertilizers plus liquid, highlighting its nitrogen content, particle size, and physiochemical properties that contribute to efficient nutrient delivery. Nano Urea Plus liquid offers a concentrated, stable, and easily absorbable nitrogen sources, leveraging nanotechnology to maximizing crop uptake, minimize wastage, and enhance overall agriculture sustainability. Uh, Technical specification of nano DAP liquid, focusing on its nutrient content, particle size, and formulation characteristics that enhance phosphorus and nitrogen delivery to crop. A reduced chemical load with less total fertilizer needed, farmers can lower cost and minimize pollution. Nano DAP liquid combines nanoscale technology with phosphorus and nitrogen to offer a highly efficient, stable, and use-friendly fertilizer option by improving nutrient delivery and cutting wastage. It supports sustainable farming and higher profitability for growers. Nano fertilizers and chemical fertilizers across several key parameters illustrated how nano formulation can offer improved efficiency and reduce environmental impacts. Solubility, dispersion of mineral nutrients, soil absorption, fixation, bioavailability, nutrient efficiency, controlled release, effective duration of release, loss rate. Overall, nanofertilizers present a next generation solution to many problems based by conventional fertilizers, combining precision delivery, environmental responsibility, and enhanced productivity. Negative consequences of excessive or improper chemical fertilizer use on soil, water, the border environment, crop health, and human well-being. This slide explained by nanofertilizers are increasingly improvement for Indian agriculture, focusing on their efficiency, environmental benefits, and economic advantage. By increasing efficiency and reducing chemical load, nanofertilizers present a sustainable solution that benefits farmers, consumers, and the environment, aligning well with Indian goals for agriculture productivity and food security. Nanofertilizers as a sustainable alternative to conventional chemical fertilizers, aiming to achieve environmentally clean agricultural production. Nanofertilizer offering a clean, efficient, and potentially transformative approach to fertilizer management. They maximize yields, reduce environmental harm, and build reliance in crops, provided they are used responsibly. So, nanofertilizer impacts on plant growth factors. Homogeneous soil distribution, sustained nutrient release, improve water relations, and enhanced root development, boosted photosynthesis and metabolism, stress mitigation. By enhancing nutrient level, improving soil plant intersections, and reducing fertilizer losses, nano fertilizers represent promising innovation for sustainable agriculture, uh, provided they are applied judiciously, monitored for long-term impacts. How nano fertilizers can booster a, a plant defense mechanism against various abiotic stress, drought, salinity, temperature extremes by influencing signal perception and transduction pathway and stress responsive gene expression. Nanofertilizers support plants by optimizing nutrient status, modulating signaling, and promoting key productive genes and metabolistic. As a result, crops then better withstand multiple abiotic stress, maintain growth and yield, and reduce losses under challenging environmental conditions. How nanofertilizers are reduced and the various methods used to encapsulate nutrients within nanomaterials for controlled release and enhanced crop uptake. How does nanofertilizer work? Nano fertilizer function, particularly nano urea, by dilating their entry into leaf tissues, translocation through the plant, and gradual release of nutrients. Foliar application of rapid entry, interdistribution via phloem, and transferry storage and slow release, microscopic evidence by entering leaves more efficiently, traveling through the phloem and releasing nitrogen gradually. Nanofertilizers significantly boost nutrient use efficiency, reduce application rates, and support healthier, more productive plants, all while minimizing environmental impact. Advantage of nanofertilizers over traditional bulk fertilizers, focusing on efficiency, sustainability, and economic benefits. Nanofertilizers represent a revolutionary approach of fertilizer management, reducing chemical loads, cutting costs, improving yields, and preserving environmental quality. And they not only benefit farmers through higher benefits and better crop outcomes, but also support national and globally sustainable efforts in agriculture. Nano urea in the India fertilizer scenario. Nano urea is released to transform India fertilizer landscape by replacing conventional 45 kg urea bag with 50 ml, only 50 ml nano urea bottles. So these consideration highlights both the economic potential and the sustainability factors associated with nano urea, pointing toward a significant shift in India's agriculture input. My research findings. This is my experiment site located in ICR Central Soil Sanitary Research Institute, Karnal, Haryana, India. My design is RBD simple, 3 replication treatment combination 7. Total number of plots 21. Plot size is 3 meter by 3 meter. Crop my rice in rainy season and variety is CSR 30. My research objectives is evaluate the effect of nano nitrogen and nano phosphorus fertilizers, analyze nutrient uptake patterns, investigate how different nitrogen and phosphorus management practices influence nutrient uptake in these crops, assess economic feasibility, determine cost effectiveness of nano fertilizer based on nitrogen and phosphorus management in the rice crop. These helps clear field management practices and experiment methodology, offering insights into how nano fertilizers might influence rice growth under the reclaimed sodic soil. This is my treatment. First one is T1, absolutely control. In treatment second, only farmer practices. Then treatment 3, 75% nitrogen plus 1 nano urea spray at peat flowering. And fourth one is 75% nitrogen and phosphorus with 1 nano DAP spray at maximum tillering and 1 nano urea spray at peat flooring. And then 3.5, 75% nitrogen phosphorus plus nano DAP with seed priming plus nano urea spray at peat flooring. 50% then treatment 6, 50% nitrogen and phosphorus plus nano DAP seed priming and 1 nano urea spray at jointing stage and 1 nano urea spray at peat flowering. Then 50% nitrogen phosphorus treatment 7 nano DAP seed priming plus 2 nano urea spray and 2 DAP spray, nano DAP spray. Full nitrogen and phosphorus and potassium as basal, nitrogen 2 or 3 splits as per treatment, RDF for rice in basmati rice 60 33 30 30 60 kg per hectare nitrogen, 30 kg per hectare phosphorus and 30 kg per hectare is put. How substitute conventional nitrogen and phosphorus with nano fertilizers? Influence key morphological traits of rice. Each var T1 through T7 is segmental into 3 components: plant height, fresh weight, and dry weight. So, nano fertilizer strategy, especially partial substitution of conventional fertilizer, improve rice growth, reduce environmental impact, and potentially enhance farmer profitability. Yield related traits in rice under nano nitrogen substitution and phosphorus. T7 generally exhibit the best performance across all yield attributes, indicating that 50% conventional and nitrogen phosphorus combined with nano urea and nano DAP seed priming multiple foliar spray can surpass the full recommended dose of fertilizers. However, unfilled grains in T6 and T7 imply better nutrient availability throughout the grain filling stage. Even though less conventional fertilizers is used in T6 and T7, the improved nutrient use efficiency from nano fertilizers leads to enhanced yield components. Optimizing fertilizer strategy for sustainable rice production, balance cost, efficiency, and environmental impact. This stacked chart compares 6 key yield attributing traits of rice across 7 treatments, 1 to 7 on the x-axis. Each bar is divided into colored segment represent. Total number of tillers per plant is blue indicate number of effective tillers plant, panicle length, branches per panicle, filled grains per panicle, unfilled grains per panicle. The chart is likely using a single numerical scale to stack these traits so the height of each bar reflect the summation of values for all 6 parameters, not just one traits. How partial substitution of conventional fertilizers with nano fertilizers, especially T6 and T7, optimize yield, reduce chemical use, and potential increase profitability for farmers. Yield-related traits of rice under nano nitrogen and nano phosphorus substitution. Total grain weight per plant, biomass dry weight per plant, 100 seed weight. In this slide, T6 and T7 demonstrate that partial substitution of conventional nitrogen phosphorus with nano fertilizers significantly enhance rice yield and seed quality. This approach optimizes nutrient efficiency, cut down on fertilizer inputs, and may have the way for sustainable high yielding agriculture. Compress 3 yield related parameters of rice: total grain weight per plant, biomass dry weight per plant, and 100 seed weight across 7 treatment. Each parameter is grouped especially on the x-axis, and within each group there are 7 bars representing the different treatments. So side by side comparison of T7 and T1. T7 plant height and canopy density. In T7 plant appear taller with a dense upright canopy and numerous tillers. And then T1, in T1 plant looks shorter with a thinner canopy of fewer tillers overall. Leaf color and health, tillering and stem vigor, and soil and field conditions. Nano fertilizer use efficiency. T7 benefits for enhanced nutrient uptake and reduced losses due to nano urea and NPK. Lower conventional fertilizer, higher nutrient use efficiency. despite using only 50% conventional nitrogen and phosphorus. T7 is multiple nano fertilizer application, seed priming for foliar spray, supply nutrients at critical stages, boosting growth, control plot deficiency. T1 has no external nutrient input, so plants easily slowly on native soil fertility, leading to extended growth and reduced vigor. And then side by side comparison of T1 and T2 RAS plot, and then T3 and T7. Future prospect, future purpose and research directions for nanofertilizers, mechanization and kinetics of nutrient release. Most studies compare nutrient release patterns of nanofertilizers versus conventional fertilizers, but detailed mechanistic insights how nanoparticles interacted with soil colloids or plant roots are still limited. In depth of investigation of nanofertilizer dissolution rates, particle transformation in the rhizosphere, and molecular level plant uptake process influence on plant biochemistry and physiology. How do nanofertilizers affect enzymatic hormonal balance or stress tolerance in plants? Multiple omics approaches, transcription omics and proteomics metabolism uncover biochemical pathways, trajectories by nanofertilizer application, soil physiochemical and biological interactions, economic feasibility and environmental compatibility, and impact on crop ecosystem services and human health. And then conclusion. The nanoparticles, especially nanofertilizers, offer a promising route to reduce reliance on chemical fertilizers at the farmer field level. Multiple studies indicate improved crop growth and yield under challenging conditions. Nano-based formulations can help achieve an environment-friendly approach on agriculture while chemical inputs, enhancing nutrient distribution and minimizing pollution. Thank you so much. My presentation is open for discussion.
Any questions?
Any question?
Any questions?
Άσε με κυρά μου τώρα γιατί έχουμε θέμα. Δεν μου ανοίγει την τέτοια. Κοίτα να δείτε ρε παιδιά.
Thank you, sir. Thank you for your participation. You will be getting the participation certificate within 2 to 3 days and a soft copy of booklet.
Thank you so much, ma'am. Thanks.
Now, I would like to request Dr. Maria Antonosopoulou, founder of Respond on Demand Tourism Marketing Company and chairwoman of World Food Travel Association, Greece, to start with speaker presentation.
Hello all, please allow me to share the screen. Do you allow me to continue?
Yes, ma'am. Please start your presentation.
I hope you see it.
Yes, ma'am. It's visible.
Thank you. So, good morning, everyone. I am Maria Athanasopoulou. I am the founder of Respond on Demand Tourism Marketing Company. I have the honor to serve as the chairwoman of the World Food Travel Association. I'm also an ambassador in Green Destinations and an instructor at the Culinary Heritage workshop. Today, we will speak about rural flavors, encasing tourism experiences through gastrotourism introduction. It's a pleasure to be here today, and I'm excited to introduce you to a rapidly growing and innovative field of tourism known as gastro-agrotourism. As we continue to explore new ways to engage travelers, gastro-agrotourism offers something truly unique, a blend of gastronomy tourism, which centers around food and drink, and agrotourism, which focuses on rural life and agricultural experiences. This combination not only allows tourists to connect deeply with the local food and culture, but also provides them with hands-on experiences in nature, showcasing the authentic roots of the products they consume. In this presentation, I will explain what gastro-agrotourism is, why it is gaining popularity, and how it can shape the future of tourism. I will also discuss the essential role of local products and communities in its development and how we can promote this form of tourism effectively to meet the demands of modern travelers. So, what is gastro-agrotourism? Let's start by understanding what we mean by gastro-agrotourism. As I mentioned earlier, this is a combination of two types of tourism. First, gastronomy tourism. This focuses on food and beverages. Travelers engage in culinary experiences, such as dining at local restaurants, food tours, cooking classes, or tasting local specialties. Agrotourism. This is centered on agricultural experiences. Tourists visit farms, learn about cultivation and production methods, and experience rural life firsthand. When these two forms of tourism come together, they create a special kind of travel experience that takes place in rural settings where food and drink are produced. Tourists don't just eat a meal at a restaurant, they see where the ingredients come from. They participate in the production process and they connect with the land and the people who cultivate it. The connection to nature. One of the key elements of gastro-agrotourism is the connection to nature. The experiences take place in natural environments, vineyards, olive groves, farms, where tourists can enjoy the beauty of the countryside while learning about the production of food and drink. This connection to the land is what sets gastro-agrotourism apart from other forms of tourism. In our increasing many people long for a return to nature. Gastro-agrotourism allows them to escape the hustle and bustle of city life and reconnect with the environment. For many tourists, this is a refreshing and restorative experience, whether it's walking through a vineyard in Italy or spending time in a family-run olive farm in Greece. These experiences allow tourists to slow down and appreciate the beauty and tranquility of rural life. But why is gastro-agrotourism becoming so popular? The growing popularity of gastro-agrotourism is driven by several factors. Tourists are becoming more conscious about their impact on the environment and local communities. Many travelers now want to engage in sustainable tourism, which aims to minimize negative impacts on the environment while benefiting local communities. Gastro-agrotourism supports sustainable travel by promoting local products, reducing the carbon footprint associated with food production, and encouraging the preservation of traditional farming methods. By visiting local farms, vineyards, and olive groves, tourists are not only gaining a deeper understanding of where their food comes from, but they are also supporting the local economy. In many cases, the farms they visit are small, family-run businesses that depend on tourism to survive. Gastro-agrotourism provides these businesses with a new source of income and helps them to share their passion for farming with a broader audience. Examples of gastro-agrotourism experiences. Let's dive into some real-life examples of what gastro-agrotourism looks like. 1. Wine tourism. Imagine walking through a vineyard, breathtaking the fresh air, and learning about how grapes are grown at harvest. You get to tour the wine cellar, see the barrels where the wine is aged, and finally enjoy a tasting session. In regions like Bordeaux, Napa Valley, wine tourism has become a significant draw for tourists. 2. Olive oil tourism. In places like Greece, Spain, and Italy, olive production is a centuries-old tradition. Tourists visiting olive groves can see how olives are harvested and then pressed to create high-quality olive oil. They can taste the fresh oil, often paired with local bread, cheese, or salads. These tours often end with a meal where olive oil is the star ingredient, giving visitors a complete sensory experiences. Honey tourism. In honey tourism, tourists visit a place to see beekeepers at work and learn about the vital role bees play in pollination. They can observe how honey is extracted from the hives and sample different types of honey. Some tours even allow guests to participate in the harvesting process, making the experience interactive and educational. Herb and spice tourism. In many parts of the world, herb and spices are integral to local cuisine. Tourists can visit farmers where herbs are grown. They can take part in harvesting and learn about how these ingredients are dried and processed. Often, these experiences include a cooking class where tourists use the herbs in traditional recipes. Each of these experiences shares a common thread. Tourists are not just observers, they are participants. Local products as the heart of gastro-agrotourism. Local products are the stars of gastro-agrotourism. Whether it's wine, olive oil, honey, or herbs, the focus is always on food and drink that is deeply connected to the land and culture of a specific region. These products tell the story of the place where they are made. They reflect the climate, the soil, the traditions, and the people. For tourists, tasting local products in the place where they are produced is a powerful experience. It gives them a deeper connection to the region and a greater appreciation for the hard work that goes into creating these products. Many tourists will even take these products home with them, allowing them to relive their experiences and share them with family and friends. For local producers, gastro-agrotourism offers a unique opportunity to showcase their products to a global audience. It allows them to tell their story, share their traditions, and connect directly with consumers. This direct connection can help to strengthen the reputation of their products and increase demands for them in international markets. The role of community in gastro-agrotourism. One of the most important aspects of gastro-agrotourism is the role of the local community. This form of tourism is deeply rooted in the local culture, traditions, and way of life. It is not just about the food and drink, it is about the people who produced it. In many cases, gastro-agrotourism involves multiple members in the community working together to create a memorable experience for tourists. Farmers, chefs, tour guides, and local artisans all play a role in shaping the tourist experience. This creates a sense of community and ensures that the benefits of tourism are spread across the local population. Moreover, gastro-agrotourism often encourages tourists to stay longer and explore more aspects of rural life. They may visit local markets, attend cooking workshops, or participate in seasonal festivals. These additional activities further enrich the tourist experience and contribute to the local economy. Promoting gastro-agrotourism, strategies for success. Now that we understand the importance of gastro-agrotourism, how can we effectively promote it? 1. Clear branding. First, we need to clearly define what gastro-agrotourism is and what it offers. This will help to create an identity for this type of tourism, making it easier for tourists to understand and seek out these experiences. 2. Highlighting authenticity and sustainability. The key selling points of gastro-agrotourism are its authenticity and sustainability. Tourists want to know that they are engaging with real local culture and that their visit is helping to support local communities and protect the environment. Marketing efforts should focus on these aspects. 3. Collaboration with local communities. As we discussed, gastro-agrotourism is a community effort. Local producers, farmers, and artisans should be involved in the promotion of this type of tourism. 4. Targeted marketing. Different markets have different preferences when it comes to tourism. For example, European tourists may be more interested in wine and olive oil tourism, while tourists from Asia may be more interested in herbs and spices. Understanding these preferences and tailoring marketing efforts accordingly will be the key to the success of gastro-agrotourism. Creating a year-round experience. One of the challenges of gastro-agrotourism is that many agricultural activities are seasonal. However, we can create a year-round tourist product. For example, in the winter months, tourists can focus on food preservation techniques such as curing meats or making jams, while in the summer they can participate in harvesting activities. Conclusion. In conclusion, gastro-agrotourism represents an exciting and promising future for the tourism industry. By combining the best of gastronomy and agrotourism, it offers tourists a unique opportunity to connect with the land, the people, and the food of a region in a meaningful and immersive way. As more travelers seek authentic, sustainable, and enriching experiences, gastro-agrotourism is well positioned to meet their needs. It not only benefits the tourists who enjoy these experiences, but it also supports local communities, preserves traditional agricultural practices, and promotes sustainable travel. Let's continue to explore and promote this growing field of tourism, ensuring that both travelers and local communities can enjoy the rich flavors and cultural heritage that rural life has to offer. I want to thank you. I'm sorry I have to leave the meeting because I'm on a business trip, but I am at your disposal if you need any clarification. The organizers knows my mail, etc. Thank you very much.
Any questions? Any questions to Maria? Thank you, ma'am. Thank you for your participation. You will be getting the participation certificate within 2 to 3 days and a soft copy of booklet. Now, I would like to request Safeh Skendri, Muhammad Dwi, Polytechnic University, Ben Guer, Morocco, to start with speaker presentation.
Yes, hello everyone. I'm going to share my screen with you shortly. Is my screen visible to everyone?
Yes, ma'am.
All right. So Good morning, everyone. I am Dr. Safa Askandari, and today I will be presenting our work on the development of a rapid molecular detection test for Salmonella. So I'm excited to share with you how we can revolutionize Salmonella detection with a faster, simpler, and a more accessible approach, one that could make a real difference in protecting public health and reducing foodborne outbreaks. So let's dive in. Salmonellosis remains a major public health concern, and according to the World Health Organization, 1 in 10 people globally suffer from foodborne illnesses each year, leading to the loss of 33 million years of healthy life. And beyond human health, Salmonella has also serious implications for food safety and economic losses, especially in the poultry sector, which generates a turnover of nearly 36.9 billion dirhams in Morocco. It is the second most reported zoonotic disease, which means it passes from animals to humans, with over 65,000 cases recorded in 2022. So this highlights the urgent need for improved detection and prevention strategies. So to minimize the risk, Salmonella detection must occur well upstream in the food chain, from farms to processing facilities. This means testing raw materials such as meats, eggs, fruits, and vegetables before they enter the food chain supply. So currently there are 2 main approaches used for detecting Salmonella: bacteriological culture methods and molecular techniques such as PCR, polymerase chain reaction, which are still considered the gold standard for Salmonella detection. Bacteriological methods, such as the ISO 6579 standard, are widely used, but they require up to 5 days to yield results. PCR is faster, but has major drawbacks, including high cost, the need for specialized equipment, and the requirement for DNA extraction. These limitations make standard methods impractical for rapid on-site testing in food production facilities. So to summarize, traditional detection methods have several challenges: the slow processing time, the high cost, they require skilled personnel, and the contamination risks. And overall, they are not suitable for field application. And given that poultry products often have a short shelf life, generally less than 6 days, faster solutions are essential. This brings us to our research project, which is developing a molecular test for the rapid detection of Salmonella that is at the same time cost-effective, field deployable, easy to use and to interpret, and is less risky for operators. So our chosen alternative is the loop-mediated isothermal amplification, or LAMP for short, which is a molecular method invented in the year 2000 by the ICON company. And unlike PCR, LAMP does not require thermal cycling. It amplifies DNA at a constant temperature using special DNA polymerase and that has a strand displacement activity. The amplification is rapid and it allows for visual detection of the results. Its key advantages include faster results, which can be obtained from 30 to 60 minutes. Its high sensitivity and specificity. There is no need for expensive equipment, and the visual detection of amplification is possible. However, LAMP has also some challenges, such as complex primer design and limitation in multiplexing. But despite this, it remains a powerful tool for rapid on-site pathogen detection. So LAMP operates at a fixed temperature of 65 degrees Celsius using a special strand displacing polymerase enzyme and employs 3 to 4 primer sets to create a loop structure, which is going to enable continuous and factorial DNA synthesis. Unlike PCR, LAMP does not require thermal cycling, which makes it faster and more accessible. The reaction can be monitored visually, meaning a simple color change can indicate the presence of the bacteria without the need for advanced lab equipment. So our objective was to optimize this method to make it more practical for food safety applications. So developing a robust LAMP assay requires several key steps. First of all, finding a conserved Salmonella sequence or a conserved footprint and designing effective primers. After that, there is the need for optimizing the reaction conditions and evaluating its performances. And lastly, prototyping and validation. So we carefully selected the HeLa gene, which is a well-known virulence gene specific to Salmonella. Different sets were designed and tested. The best combination was confirmed using intercalent agents and visualized under UV lights, as well as on electrophoresis gel, ensuring high specificity for detection. But using those methods as amplification detection tools only work on a lab setting and add another step to the amplification process, which might introduce contamination. And so, to simplify detection, we integrated a phenol red-based colorimetric indicator into our LAMP reaction, which is not only cheap, but is also highly compatible with the LAMP pH range. The principle is simple. The release of protons during amplification leads to the acidification of the reaction, which then allows a color shift from an initial pink color to a bright yellow. So in short, a pink color means a negative reaction, and the yellow color, on the contrary, means a positive amplification. So this eliminates the need for fluorescence or gel electrophoresis, making the tests more accessible. So the LAMP test is also highly performative. We can detect up to 1.2 UFCs per reaction, and the sensitivity is comparable to that of the real-time PCR. The test is also highly specific. There are no cross-reactivity with non-Salmonella bacteria, and we can detect both mobile Salmonella, which pose a threat to human health, and also non-mobile ones that are important for poultry sector, considering the damage it can cause. Our results confirm that LAMP is a reliable alternative for rapid Salmonella detection. And to further optimize the method, we replaced genomic extraction using commercial extraction kits with a thermal shock procedure, which showed similar results to commercial kits and is more adaptable to an on-field use. So all of these optimizations allowed us to develop a prototype based on chicken meat, considering its importance to human health, agri-food industry, and the poultry sector. Our prototype allows us to start from a chicken sample, which is then washed using a buffered washing solution to stabilize its pH. The sample is then heat treated to collect DNA and amplified using the LAMP test for a rapid visualized detection. So to conclude, our LAMP-based Salmonella test offers significant advantages. The detection is under 2 hours, allowing rapid response and loss prevention at the same time. It is cost-effective. It's considered to be 2 or 3 times more cheaper than standard methods, and is highly sensitive, which allows it to be the perfect safeguarding tool for food safety. And what is even more interesting is that it is easily adaptable to other foodborne pathogens. So in short, this innovation contributes to improving food safety by enabling faster responses to contamination risks, ultimately reducing economic losses and protecting public health. So I would like to express my gratitude to my supervisors, Dr. Abdelawi Iman and Professor Sadia Nasik, as well as the funding institutions, the University Mohammed VI Polytechnic, the OCP Group, and the Ministry of Higher Education of Morocco. And I would like to lastly add that research is the driving force behind national and international development. So let's all work together for an applied and practical research. Thank you very much for your attention.
Any questions to Safar? Any questions? Thank you, ma'am. Thank you very much for your participation. You will be getting the participation certificate.
Thank you so much.
Within 2 to 3 days and a soft copy of booklet. Thank you. Thank you very much. Now, I would like to request Mr. Melusi Nondo, Midland State University, Zimbabwe, to start with speaker presentation.
Hello, everyone. Thank you for joining me today on Zoom. So my name is Melusi Nondo from Midland State University in Zimbabwe. I'm a food scientist with a passion for food preservation. So I'm a student at Midland State University. Can you hear me?
Yes, sir, you're audible. Please go with your presentation.
Okay. So food preservation is the process of treating, handling food in such a way as to stop greatly slow down spoilage to prevent foodborne illness and extend its shelf life. So food processing methods and preservation methods that are used to preserve foods include refrigeration, freezing, canning, irradiation, dehydration, pickling, pasteurization, fermentation, as well as many other methods that you can use, such as Heckley technology. So why do we preserve food? So it's a question that might be asked. So it saves money, home preserves cheaper, it avoids waste, food available out of season, variety in the diet, preserved food can be more convenient, preserved foods can be transported long distances. It creates new flavors, salting, smoking, jam, etc. So the general principles of preservation, number one is to destroy or inactivate enzymes. Number two, to destroy and inactivate microorganisms. Number three, to prevent the re-entry of new microbes by sealing food. Lastly, to maintain the nutritive value, color, flavor, texture of the food as far as possible. So preservatives. So an ideal preservative should meet the following criteria. Number one, can inhibit the growth of a wide range of microorganisms. It should be non-toxic to humans. It should not be expensive. It should not affect the flavor, taste, aroma of the food product. It should not be inactivated by the food itself. It should not promote the development of resistant microorganisms. It should also kill rather than inhibit the microorganisms that are responsible for food spoilage. So here is a table of different types of preservative and in which they target the organisms, action, and examples of food applications in food. So number one, we've got sulfites. So yeast, they target the yeast and bacteria. So the action is antioxidant, dehydrated foods, and vegetables, wine, juices, and sausages. Sodium nitrite, we target the bacteria, which is antimicrobial activity, cures the meats. Sorbic acid, molds, antimicrobial cheeses, cake, salad, dressing, and wines. Benzoic acid, yeast, and molds. So the action is antimicrobial, so it is mainly used in soft drinks, in ketchup, and salad dressings. So these are the food preservation methods, whereby they can be done through inhibition, inactivation, and avoid recontamination. So we start about the food additives. So someone might decide to know the definition of food preservatives, whereby these are substances added to food to achieve specific effects such as improving flavor, texture, appearance, or nutritional value. So they can be classified into several categories, including preservatives, colorants, etc. So food preservation employs a variety of chemicals and additives to manage pH levels, which serve as antimicrobials and antioxidants and enhance food functionality. So these additives can be characterized into two main types, which are synthetic additives and natural additives. So synthetic additives, these are compounds not found in nature, such as tertiary butyl hydroquinone, which is used for its antioxidant properties. So natural additives, these are substances derived from natural sources like vitamin E, which also serves as antioxidant. Regardless of their origin, food additives must fully fulfill the specific functional roles and be safe for consumption under intended usage conditions. So the common preservatives, So many preservatives legally permitted in the food include organic acid and esters. So the notable examples of those are organic acids such as sulfite, nitrites, acetic acid, citric acid, lactic acid, sorbic acid, benzoic acid, and various parabens. So these substances play crucial roles in inhibiting microbial growth and extending the shelf life of the product. Artificial preservatives. So there are several types of artificial preservatives food. For example, antimicrobial agents which prevent the growth of molds, yeast, and bacteria. So the antioxidant, they then suppress the reaction when food comes into contact with oxygen, heat, and some metals. So there's chelating agents which keep foods by suppressing the reaction of foods with metal ions. So the mechanism by which preservative exert their effects, so they say these involve the establishment of equilibrium between undissociated acid molecules and their charged anions when dissolved in water. So as the pH decreases, the proportion of undissociated acid increases, which enhances their efficacy. So the undissociated acid molecules are lipophilic, enabling them to diffuse readily across the microbial cell membranes. So once inside the cytoplasm, these acids dissociate into charged ions and protons, which cannot easily cross the lipid bilayer, leading to an accumulation of protons. This accumulation lowers the internal pH, thereby inhibiting the microbial metabolism. So another technique for food preservation is smoking. So smoking is one of the oldest preservation techniques, as you see the picture that has been attached. So this imparts both flavor, color to food while providing a preservative effect through the compounds formed during the smoking process. So it appears that compounds present in wood smoke have antibacterial action that prevent the growth of organisms that cause spoilage. Although primarily used with meat and fish, smoking can also contribute to drying, which further inhibits the microbial growth as moisture content is being lowered in the product. So there's also the role of pH in food preservation. So the hydrogen ion concentration measured as pH is a critical factor in regulating numerous chemical, biochemical, and microbiological reactions. So foods with a pH below 4.5 are considered low risk and require less stringent heat treatment. At a pH level below approximately 4.2, most food poisoning microorganisms are effectively controlled. The effectiveness of various preservatives largely hinges on their ability to equilibrate across microbial cell membranes in their undissociated forms, thereby interfering with the pH gradient maintained by the cell. So alongside the weak lipophilic acid preservatives include benzoic acid esters, inorganic acid, which are particularly effective at lower pH levels. We go to another method, which is enzymatic preservation, whereby we're using enzymes. So there's antimicrobial enzymes, which have a potential to degrade undesirable polysaccharides and enhance preservation. For example, if we look at the lysosome from hen egg whites, it has been recognized for its effectiveness against spoilage in specific food products, such as hard-cooked cheese. We go to another one, which is ionization radiation, which interacts with materials by transferring energy to electrons, creating positive and negative ions. So the irradiation process involves exposing food, either prepackaged or bulked, to a specific level of radiation. So ionization is creation of ions in the irradiated food by a gamma or electron beams. So there's a maximum dose of 10, a destruction of the pathogen, food deteriorating floras, destruction of deteriorating enzymes. So this is a logo that is used on ionized food. So it conserves the nutrition such as vitamins, proteins, flavor, except lipids. So ionization radiation is effective for food disinfection, extending shelf life, decontamination, and improving product quality. So UV radiation is known for its antibacterial properties and is primarily used for sterilization air and thin, So UV radiation is known for its antibacterial properties and is primarily used for sterilization air and thin liquid films due to low penetration. So high doses of UV can lead to flavor and odor deterioration before effective sterilization. So it is considered safe, environmental friendly, and more cost effective than traditional chlorination. There's another one which we call photoreactivation, whereby microorganisms treated with certain dyes become sensitive to visible light, enhancing damage. So white and UV light can inactivate bacteria, fungi, spores, viruses, protozoa, and cysts. So there's pulse light, whereby rapid sterilization method effect for packaging materials and various surfaces generating by ionizing xenon gas-filled lamps. Irradiation is the exposure of food material to radiation, a strong advantage over conventional methods of preservation because it does not lead to loss of flavors, odor, texture, or quality, which are the organoleptic properties. So the process involves controlled application of energy such as gamma rays, X-rays, and accelerated electrons. So application of doses of radiation can arrest the sprouting of potatoes and onions. Freezing is the process of chilling food at least 0 degrees Celsius, whereby there's a deep storage and the blast freezer, whereby we're saying deep storage temperature, they're below at -6 degrees Celsius to -25 degrees Celsius or lower. So the blast freezer, the temperature may be lower than 35 degrees Celsius. So temperature being so low that food turns into ice and remain in that state to preserve food's natural colors and flavors better than refrigeration. This method is used to store large amounts of food for a very long period of time using deep freezers or freezers. This is mainly used in our homes, daily life situation. We go to salting. It's a preservation method of food with dry edible salt. It is related to pickling, preparing food with brine, that is salty water, and is one form of curing. Salting is used because most bacteria and fungi and other potential pathogenic organisms cannot survive in a highly salty environment due to hypotonic nature of salt. So any living cell in such an environment will become dehydrated through osmosis and die or become temporarily inactivated. So pickling is the process of soaking food in a solution containing salt, acid, or alcohol. It can be used with most foods. Most methods require no special equipment. However, pickled foods can be unsafe if prepared carelessly or stored at room temperature. Pickling is often combined with another method such as refrigeration, canning, and fermenting. Sugaring. So it's the process of desiccating a food by first dehydrating it, then packing it with pure sugar. This sugar can be crystalline in the form of table or raw sugar, or it can be a high sugar density liquid such as honey, syrup, or molasses. So the purpose of sugaring is to create an environment hostile to microbial life and prevent food spoilage. So sugaring is commonly used to preserve fruits as well as vegetables such as ginger. You can also preserve these fruits using the edible coating or the edible film, as our presenter said before. So vacuum packaging is another method for food preservation. So it is a method of packaging that removes air from the package prior to sealing. This method involves manually or automatically placing items in a plastic film package, removing air from inside and sealing the package. So shrink film is sometimes used to have a tight fit to the contents. Purpose of vacuum packaging: to remove oxygen from the container and to extend the shelf life of the foods, and with flexible package forms to reduce the volume of the contents in the package. It is commonly used to store dry foods over a long period of time, such as cereals, nuts, cured meats, potato chips, and biltons, an example of cured meat. So vacuum packaging can also be used to store fresh foods, such as vegetables, meats, because it inhibits the bacterial growth. Refrigeration is another method of food preservation. It is a short-term method and temperatures are maintained between 0 degrees Celsius to 5 degrees Celsius. So this is whereby enzymatic and microbial changes in food are slowed down considerably. Perishable foods like eggs, dairy products, etc. are stored in the refrigerators. Pasteurization. So the process of heating milk or any liquid media for a certain period of time to destroy or suppress the growth of bacteria is known as pasteurization. So there are 3 types of pasteurization methods, which is LT-HT, HT-LT, UHT, low temperature, high time. So 62 degrees Celsius for 30 minutes. High temperature, low time, that is 72 degrees Celsius for 30 to 60 seconds. And then the UHT is 135 degrees Celsius for 2 seconds. So the purpose of pasteurization, number one, is to increase the milk safety for the consumer by destroying diseases and causing microorganisms or pathogens that may be present in the milk. So to increase keeping quality of the milk products by destroying spoilage, microorganisms, and enzymes that contribute to the reduced quality and the shelf life of the milk. So pasteurization, it was invented by the French scientist Louis Pasteur during the 19th century. Sterilization. So it's whereby we are heating for 30 seconds between 135 degrees Celsius to 150. So this is whereby there is a destruction of all microorganisms and enzymes. So it's a long time of conservation, destruction, or some interesting nutritious properties. If we look at milk, so there's vitamin A, D, C, B1, B2, and B6. So milk without any heat treatment, it would be for vitamin A is 4.04 milligrams of vitamin A. And then after sterilization, it will be now 0.55. Vitamin D is 21 micrograms, 0.30 up to B6. So pasteurization versus sterilization, the differences. So we're going to look in terms of the function, temperature, advantage, and the disadvantage. So the function of pasteurization it is the partial destruction of microorganisms. And then sterilization is the complete destruction of microorganisms. So the temperature, which is commonly used for pasteurization, is below 100 degrees Celsius, and for sterilization, temperature 100 degrees Celsius and above. So the advantage, there's a minimum damage to flavor, texture, and nutritional quality. And then for sterilization, long shelf life, no other preservation method is necessary. Disadvantage, short shelf life, another preservation method must be used, such as refrigeration or freezing for pasteurized foods. For sterilization, food is overcooked. Major changes include texture, flavor, and nutritional quality. So with canning, so canning is the preservation of food in sealed container by sterilizing the food with heat is called canning. So there are 6 steps involved in canning process. Number 1, there's cleaning, blanching, exhausting, sealing the container, sterilizing the steel container, and cooling it. So this is a suitable method to preserve high and low acidic foods, and food can be stored longer than other preservative methods. Removal of moisture is another method for food preservation, whereby we're looking at drying and dehydration. Microbes require moisture for their growth. If water is removed from the food, the spoilage causing microbes can't grow. So dehydrated food is easy to handle in considerable light and less volume due to loss of water or moisture, such as milk powder. So there are different types of drying methods, such as oven drying, heat drying, sun drying, tray drying. Those may be applied. So we've got the difference between dehydration and sun drying. So a faster process is dehydration, while sun drying is a slower process. Dehydration happens under controlled hygienic conditions, sun drying under open air conditions with legal hygienic control. So dehydration is not dependent on the weather. Sun drying is not possible in cloudy weather or rainy days. So dehydration investment on machinery and processing cost is needed. For sun drying, there's no machinery and processing cost needed. So there's a Hartley technology, which is a food preservation method that combines the multiple preservation techniques to inhibit microbial growth while maintaining food quality and safety. So the principle of Hartley technology uses a synergistic approach where different preservation techniques create a hostile environment for microorganisms. Instead of a single method, for example, high heat, it balances multiple mild techniques to achieve microbial growth with minimum impact on food properties. So common hacklers in food preservation, they include temperature control, whereby there's refrigeration, freezing, pasteurization, pH adjustment, such as acidification, for example, vinegar, and the use of citric acid. There's water activity reduction, such as drying salt, salting, sugar preservation, chemical preservative, organic acids, nitrites, antioxidant, biological barriers, use of bacteriocins such as niacin and probiotics. So these, they help in predictive microbiology by analyzing microbial survival under multiple preservation conditions. So it is also used in the challenge testing to determine microbial resistance to various cycles. It also ensures shelf life extension and pathogen control in food products. So thank you for your attention. Any questions?
Any questions? Thank you, sir. Thank you for your participation. We will provide an online ebook and certificate within 2 to 3 days.
Okay, thank you very much.
Thank you so much for your participation, sir.
Now, I would like to request Ms. Nooren Hanan Bintin Hamid, Prefectural University of Hiroshima Shobara Campus, Japan, to start its speaker presentation.
Hello everyone, can I start my presentation now?
Yes, ma'am. Please go with your presentation.
All right. Okay, thank you so much everyone for inviting me. So today I'm going to present my research. Right now I'm in Japan, which is at night. So good night everyone. And for people in United Kingdom, I think good afternoon for all of you. So for this conference, so my title is Auto-oxidation Behavior of Fenugreek Oil, Effects of Refining and Tocopherol Composition on Oxidative Stability. I hope that all of you can hear my voice clearly. So my name is Nur Ain Hanani binti Hamid, and this is my two supervisors, which is Tomoyuki Yoshino and Yukihiro Yamamoto. So briefly, this is the table of contents of my presentations. It's just like a normal presentation. We're starting with introduction and we're closing with the conclusion. So first, introduction. Let me introduce you to my sample. So this is fenugreek seed. So as we all know, fenugreek seeds actually is one of the old medicine actually, and it has a lot of medicinal attributes such as hypocholesteremic, anti-lysogenic, anti-carcinogenic, anti-diabetic, and many more. So due to its medicinal attributes, it makes it as a relevant compound to be used in the pharmaceutical and food industry. And nowadays, many research had proved countless claims for its nutraceutical properties and health benefit, and they have been reported in many scientific studies. And due to this interest, the production and the marketing of fenugreek is positively rising. So from the fenugreek seed, when we do the extraction, we will get the fenugreek oil. So this oil consists mainly of unsaturated fatty acid and significant amounts of polyunsaturated fatty acid, or commonly known as PUFA. So this polyunsaturated fatty acid, which is also a healthy actually fatty acid, and for this oil, it has a polyunsaturated fatty acid, which is alpha-linolenic acid, or known as ALA. ALA inside this oil is around 20%. So this is the chemical structure of alpha-linolenic acid, ALA, also known as essential omega-3 fatty acid. And ALA, had been a lot of research had been done. It has a lot of positive impacts to our health, such as anti-cancer, anti-inflammatory, anti-osteoporotic, anti-oxidative, cardiovascular protective, and neuroprotective effects. However, in terms of oxidation stability of oil, if the oil consists a lot of ALA, it might be prone to the oxidation. We know that ALA is good for the health benefit. However, in terms of oxidation, it might be easily to oxidize. So that's why I conduct this research, because I need to know how is actually the behavior of this oil. So this is I think it's a very brief mechanism how actually lipid oxidation can occur. So starting with the lipid molecule, and when it reacts to the factors or initiators that can affect the oxidation, such as heat, temperature, or light, it can produce a free lipid radical. When free lipid radical react with the oxygen, it will produce the lipid peroxide radical. Lipid peroxide radical, then they will act with another lipid molecule. It will produce a primary oxidation product, or known as hydroperoxide. This hydroperoxide can be detected by one analysis called as PV, peroxide value. And this hydroperoxide can undergo degradation with the existence of other factors such as metal ions, such as light or temperature. From hydroperoxide, they can be degraded into the secondary oxidation product, such as alcohol, aldehydes, ketones, and hydrocarbon. And this secondary oxidation product can be detected by one analysis called as T-bars. Secondary oxidation product normally associated with another characteristic, which is off-level, and this off-level can be detected by the sensory evaluation. So my purpose of my study is to analyze or to investigate the oxidation behavior of fenugreek oil in different conditions. And I also want to know, is it the fatty acid composition of the oils and tocopherol influence its oxidation stability? So let's move to the materials and method. For the materials and method, there are 4 sections in my research. First, I conduct the chemical properties of the oil first so that I can know what is the basic chemical compounds existed in the oil. And then I conducted 3 oxidation tests. Oxidation test 1, which is oxidation behavior of unrefined oils. For the unrefined oils, we divided into 2 oil, which is fresh oil and emulsified oil. And then we proceed to the oxidation test 2. Oxidation test 2 which is oxidation behavior of refined oil with activated carbon. And then we proceed with oxidation test 3, which is double refining. Why I call it as a double refining? Because this is where I analyze the oil that had been undergone the refining process with activated carbon, and then proceed with the refining of the silica gel. Since I already introduced about the fenugreek oil, of course, my main sample is fenugreek seed oil, and compared with the complementary sample, which is perilla oil. Both of these oil, we do not purchase in any store. We extract it by ourselves in our laboratory so that we can confirm it has undergone the similar process so that it will be a good comparison between each other in our analysis. So let me tell you a little bit how I extract my fenugreek seed in order to get the fenugreek oil. It's a very simple method, a solvent extraction method, and the solvent that we use is hexane. So this is the fenugreek seed after they have been crushed, and then we add some hexane, and then we filter, evaporated, and lastly we will got the oil. The ratio for the seed to the hexane is around 1:5. And the average percentage yield for the one-time extraction of oil is around only 3 to 5%. Similar method with the perilla seed. So this is perilla seeds that had been crushed, and then we also using the hexane to got the oil for the extractions. And lastly, this is the perilla oil. Comparing to the fenugreek oil, perilla oil we got around 30% to 40% of oil. So like I had been explained previously, for the unrefined oil, we have the fresh oil and also emulsified oil. The preparation of fresh oil had been explained, and now I explain how did I prepare the emulsion. Of course, first we need to prepare the emulsifier dilution, and in this case, we use the commercialized emulsifier, which is Twin 20. We just add some water with the emulsifier, and then we got the emulsifier dilution. And with this emulsifier dilution, we add with our oil sample, and then we homogenize it using the homogenizer, and we got the emulsion that we want. We seal and incubated in the incubator in the 40 degrees Celsius. After we incubate in the incubator, I'm sorry, and then we can extract the oil from the emulsion by using this method. So we just take the lower part of the oil, from the emulsion, and then we analyze for the future analysis. So, all right, so I explain how did I refine my oil. So from this picture, we can clearly see here, which is the sample, which is fresh oil is phenolic oil. And then when we have been refined with the activated carbon, the color had been changed. And also the yield is also changes after being refined with the activated carbon. Why actually we do the refining? Because we believe there are actually some unwanted compound or some pro-oxidant that we don't want in the oil. So it's safely to do the refining methods in order to make sure that our oil is more edible. And normally using the activated carbon, the tocopherol will be removed in the oil. So that's for the activated carbon. So the second refining method, which is refining using the activated carbon and silica gel, we use the column chromatography method. So let me explain a little bit here. So this is the column chromatography method. Why I call it as a double refining? Because the oil that had been undergo the refining using the activated carbon, we proceed with another refining, which is using the silica gel. So the oil that had been refined with the activated carbon, we treated with the silica gel here in the column chromatography, and then we obtain the oil here. So the oil that obtained in this beaker is the oil that had been undergo the double refining process. So you can see here, previously, the color of the oil from the orange to yellow, and now after undergo the double refining methods, it becomes colorless. So it means there's something more that had been removed using the refining process. And for each refining process, 80% of initial oil is targeted to make sure that the oil had been refined completely. So for the each oil that had been undergo with the carbon and silica, we store in the refrigerator for 4 degrees Celsius. So before our further analysis have been conducted. All right, so let's move to the incubation condition. Because you want to test the oxidation behavior of the oil, so it normally will take some days. So in order to make sure the temperature, the condition is similar to all samples, so we put inside the incubator. So for the oxidation test 1, we have fresh oil and also emulsified oil. For the fresh oil, we can see here, the temperature is 35 degrees Celsius and the condition is dark and the stir speed is low. For the analysis, we conduct 3 analyses, which is PV, T-bars, and tocopherol content. For the emulsified oil, so I can show you, this is the figure that how did I keep my emulsified oils inside the incubator. So the temperature is around 35 or 40 degrees Celsius, similar. Also, the condition is dark, stir speed is low, and analysis is same, PV, T-bars, and tocopherol content. So how about oxidation test 2 and oxidation test 3? As I had been explained previously, oxidation test 2 and oxidation test 3 is for the oils that have been undergo refining process. And normally, for the oil that have been undergo the refining process, a lot of compound had been removed. So sometimes, it can be assumed that the stability should be lower than the fresh oil. So that's why we reduce the temperature, previously 35 degrees Celsius, and now we treat it with the temperature 20 degrees Celsius. Condition still dark condition, the stir speed is low, and the analysis is PV T-bars. Why only PV and T-bars? Because for the tocopherol, it had been removed during the refining process, so no need to undergo any tocopherol test anymore. So this is for the chemical composition. I analyzed the lipid composition. So using the method, which is a very simple method, thin layer chromatography, I think all of us know how to conduct the TLC. We're just using the TLC plate, and of course we have to need our standard safflower oil as a TAG, pure oleic acid as the fatty acid, and phosphatidylcholine, PC of the polar lipid. So we just drop our sample, and then we compare with our standard, so we can observe the yellow spot form in the TLC plate. For the fatty acid composition, it is also the common method, just using the gas chromatography analysis, which is the DC condition, column temperature 200 degrees Celsius, detector temperature 250 degrees Celsius with the flow rate 1.9 milliliter per minute, and our detector is flame ionization detector. For the triacylglycerol TAG composition, we use the high performance liquid chromatography analysis, HPLC. The column is reverse phase ODS silica column with the column temperature 40 degrees Celsius, flow rate 1 milliliter per minute. And our detector is refractive index detector. And our mobile phase is acetone acetonitrile with the ratio 1:1. For the DPPH antioxidant activities, I think it's a very straightforward method using the UV spectrophotometer with the absorbance wavelength 517 nanometer. For the peroxide value, this is where we want to analyze the hydroperoxide or the first oxidation product of the oil. So we conduct the peroxide value. This is automatically calculated PV using the machine that when we do the titration, automatically calculated by the machine itself. So we will got the calculated PV. So if we got the higher value of the PV, it means that the oil had been oxidized. If we got the lower amounts of PV, so it means that the oil still is in acceptance condition. For the T-bars is for to analyze the secondary oxidation product. So we using also the UV spectrophotometer, but in this analysis, we not analyze all oil. We just analyze the supernatant of the sample with the absorbance of wavelength 532 nanometer. And tocopherol content, just a little bit different between two samples, but both of us undergo high performance liquid chromatography. Just all sample because it's very concentrated, so we need to reduce the amount of fenugreek oil, but still similar method. For the HPLC, we use the mobile phase hexane and isopropyl alcohol with the ratio 201. The detector is FL detector with the column temperature 30 degrees Celsius. So finally, let's move to my results and discussion. So for the chemical composition, I just highlighted the important parts only. So let's see here, ALA, alpha-linolenic acid. From our analysis, comparing with the fenugreek oil, perilla oil shows a very remarkable amount of ALA, which is around 33% compared to fenugreek oil, which is just around 26.6%. As I explained before, ALA is polyunsaturated fatty acid. So theoretically, if the oil has lots of polyunsaturated fatty acid, it will oxidize faster than the oil that had lower amount of polyunsaturated fatty acid. So theoretically, from the chemical composition, I assume that FO should have more stability, more oxidative stability compared to PO. So it's just a theoretical based on the chemical composition. So for the DPPH, once again, FO shows a very remarkable amount of DPPH, antioxidative capability. So we can see compared to the PO, FO is almost double amount, 80% versus 44%. It's clearly showing that FO has a good antioxidant activities. And one point that need to be highlighted also, for the total tocopherol contents of the fenugreek oil is excellent compared to the PO. So for the chemical composition itself, theoretically, it's saying that FO should have lot oxidative stability, should more stable compared to the PO. However, actually, in reality, this chemical composition is not enough to identify the stability of the oil unless we do the oxidation test. So that's why we decide to do the oxidation test. So when we did the oxidation test, what we got is very surprising. So we can see the orange color represent the fenugreek oil, while the dotted one representing the perilla oil. From the chemical composition, it's saying that fenugreek oil should stable more than PO, but why when we do the oxidation test, fenugreek oil is lower stability compared to perilla oil. If it has higher value of PV, it means it have a lot of oxidation product. If it has a lot of oxidation product, it means it's not stable. So we can see here for the unrefined oil, fresh fenugreek oil, it is less stable compared to PO. And then we proceed with another test, which is T-bars for the analyzing the secondary oxidation product. And it's consistent with the PV. So we can see from the T-bars, once again, FO shows less stability compared to the TO. And our final test, which is the tocopherol content, so we can see that FO is degraded. The remaining amount of tocopherol is lesser than the TO. So it supported the result from the PV, it supported the result from the T-bars, and it's clearly show that FO has lower stability. So since we believe that maybe there are compounds inside the oils, fresh oil, so we try to confirm again by using the emulsified oil. And surprisingly, emulsified oil also showing the same pattern. So we can see here the emulsified FO in the orange color compared to emulsified perilla oil, once again proving that emulsified fenugreek oil has lower stability. And we proceed with another secondary test and also supporting and in conjunction with the previous experiment, which is emulsified fenugreek oils also showed less oxidative stability. For the tocopherol content, even though it didn't show any significant value, but still from the graph, you can see that emulsified fenugreek oil also showed less stability. So we try to do the improvement. Maybe there are some compounds inside the fresh oil, either in the intact oil or either in the form of emulsified. Maybe there are pro-oxidants inside the fenugreek oil. So we try to remove the pro-oxidant by doing the refining process. And the first refining process is just using the single adsorbent, which is activated carbon. And when we do the activated carbon, we test the oscillation test. However, fenugreek oil that had been refined with the activated carbon once again show that it still has lesser stability compared to the perilla oil. When we do the secondary oscillation test, which is T-bars, is still supporting the result from the primary oscillation test. And then once again, we try to improve it by doing the double refining process after the oil that have been undergo with the activated carbon. And then we proceed to do another refining process with the silica gel. And finally, after we undergo this double refining process, FO, which is fenugreek oil, show the improvement, the enhancement for the stability, and it show very remarkable oxidative stability compared to the perilla oil. And we do the secondary oxidation test, and gladly, FO showing a better oxidative stability compared to our complementary sample, which is perilla oil. So what can be discussed with our project here? So it can be assumed that for the first part, which is oxidation test 1, oxidation of the unrefined oil, even though we can say that FO is lesser stability than PO, and it's supported even the oil in the fresh oil, and although even the oil in the emulsified form, still fenugreek oil show the less oxidative stability compared to the PO. So why this happened? After do a lot of research and discussions, and also from a lot of literature, we know that tocopherol is vitamin E. Tocopherol is a good antioxidant. However, the amount of total tocopherol or the composition of tocopherol itself also can influence the stability of the oil. From our chemical properties previously, if I can recall once again, we can see that FO shows a very remarkable amount of total tocopherol. So we can see here, FO has around 1,800 tocopherol compared to the PO, which is around 700. If the tocopherol exceeds its amount, it will become one of the factor that can influence the pro-oxidant activity of the oil. So another factor also that contribute to the instability of the fenugreek oil is actually alpha tocopherol. Even though it has a lot types of alpha tocopherol, some research saying that if the oil has a lot of alpha tocopherol, in this case, FO has high alpha tocopherol. Alpha tocopherol known for its least stability. PO, even though has high alpha linolenic acid, but it has low alpha tocopherol. So if the oil has alpha tocopherol, it's actually making the oil less stable. So this is the evidence supported by other literature. It said that actually not only fatty acid is the most effective descriptors to predict for the oxidation stability, but we also need to know the quantity of the tocopherol, tocotrienols, sterols, metals, and phospholipid. And the research conducted in 2017 saying that tocopherol is well known for having an antioxidant, but if it is present in excess, the function may be reversed. So we can assume here, maybe the amount of the tocopherol inside the fenugreek oil, even though it has high, but it already excess the optimum level, and then it reverses from the antioxidant to become pro-oxidant. If it has reversed from the antioxidant, then become pro-oxidant, it means that it will promote oxidation. So maybe that explains why in the fresh state, in the existence of the tocopherol, especially alpha tocopherol, it contributes to the least stability of the fenugreek oil. So once again, there are one research conducted but using the soybean oil and sunflower oil. Soybean oil, it has a low amount of PUFA compared to sunflower oil. However, soybean oil has high amount of alpha tocopherol. So since soybean oil have however, soybean oil have low sunflower oil actually have a higher alpha tocopherol. So normally soybean oil, if according to the fatty acid composition, soybean oil should become more stable, but because it should become less stable, but due to the alpha tocopherol which is lower than sunflower oil, so that's why soybean oil become more stable than sunflower oil. So it's actually similar cases with fenugreek oil and perilla oil, because fenugreek oil have high alpha tocopherol, even though it has less amount of PUFA. So that's why it can be assumed that it has a less stability compared to the perilla oil. Okay, so discuss for the oxidation test too. We know that tocopherol had been removed by the refining process using the activated carbon. And we can say, even though the tocopherol had been removed by the activated carbon, but the stability of the fenugreek oil still same as the oxidation test one. Fenugreek oil still has less oxidative stability. So why this happened? We can say that actually not only fatty acid, not only tocopherol, but other minor components may also influence the stability of the fenugreek oil itself. So this condition supporting the evidence that Fa and tocopherol itself not enough to become the indicator why indicator to the stability of the oil. We should consider a lot more or minor compounds that actually can contribute to the oxidative stability of the oil. Even though FO has a lower amount of Fa, even though the tocopherol had been removed using the refining process in the oxidation test 2, but still it's showing no improvement for the oxidation test 1. So we can consider that there's still pro-oxidants remain in the phenugreek oil. And then after we do another improvement by doing the double refining methods, which is oxidation test 3, finally, we got the result, which is in accordance with its fatty acid composition. Finally, stability of the fenugreek oil is higher than perilla oil. So why? First, we can agree that silica gel is able to remove the remaining active polar compound in the fenugreek oil. If the silica gel has the ability to remove the pro-oxidants, so that's why it enhances the stability of the fenugreek oil. And also, that what we need to know that silica gel is a polar compound, and the capacity to absorb phospholipid, pigments, soaps, and other minor compounds existed in the oil. So this is also supported the reason from the oxidation test 2, saying that there are remaining compounds inside the oil. So when we do the refining process with the silica gel, and finally we got the more stable oil compared to the previous oxidation test. So it supported that silica gel is actually one of the excellent adsorbent to remove the polar compound inside the oil. But one thing that we need to highlight here, it's just not only silica gel, but because we do the double refining process, so it's actually a combination, or we can say the composite compound, the combination of the activated carbon and also the combination of the silica gel. So there are research in 2012 saying that instead of just using one single adsorbent, why not we combine the compound, such as the carbon plus silica gel. By the composite compound, by combining the adsorbents, it can outperform, it can give a more better results when we compare to the only one adsorbent used. So this actually proves the effectiveness of the composite compound, as we can get the more stability of the fenugreek oil. So my conclusion of my study, for the chemical properties of fenugreek oil, we should agree that it has a better chemical composition compared to the perilla oil. It has only around 26.6% of alpha-linolenic acid, which is can consider as actually good amount of healthy fatty acid, and it has an excellent amount of tocopherol content, around 1,800, and also highest composition of alpha tocopherol. However, this is not enough, because this factor also can, from the antioxidant, might reverse to become the pro-oxidant. It proven in the oxidation test 1, due to the excessive amount of alpha tocopherol, due to the maybe over amount of tocopherol concentration, it potentially become the pro-oxidant. That's why the stability for the fenugreek oil for the oxidation test 1 is become lower than perilla oil. For the oxidation test 2 and oxidation test 3, well, it's proven, but by the double refining system, we can produce the fenugreek oil which better enhance, improve oxidative stability. So once again, it showing that by depending on the fatty acid alone or tocopherol alone is not enough to determine the oxidation behavior of any oils, especially in this case, for the fenugreek oil. We need to consider a lot of minor constituents. We need to consider the synergistic activity between the fatty acid composition itself, between the fatty acid, between the tocopherol and other minor components. All of this reactivity of the synergistic activity, we need to consider the reactivity between all the compounds inside the oil. We need to consider in order to know the oxidative stability of the oil. So that's why we need to conduct the oxidative stability of the oil, because by knowing the chemical composition alone is not enough. We need to conduct the oxidative stability so that we have the clear answer. Is it the oil is actually stable enough to introduce to the industry? So for now, we already know what is the better method to produce a stable oil, but deeper research need to conduct in order to precisely determine exactly what is the compounds that influence the oxidative stability of the oil. So that's all from me. Thank you so much.
Any questions? Thank you, ma'am. Thank you so much for your participation. You will be getting the participation certificate within 2 to 3 days and a soft copy booklet.
Thank you so much.
Thank you very much to all the participants who have joined the webinar on 7th International Conference on Food Science and Regulatory Measures. During this period, having different time zones, our most sincere thanks to all speakers, students, delegates, journal collaborators, media partners who have joined from different destinations around the globe for their support and cooperation. Let us thank speakers who have responded so well to our invitation to participate in this conference. We have received several papers which will form from basic of our discussion in the various sessions. Let us thank you all for associating with this conference by your presence. A special thanks to Mrs. Maheshwari and Sarah Klein for their continuous effort in putting us all together under one platform in this online event. I would also like to thank participants. Hope we can collaborate in future events in physical or virtual events. E-certificate, e-handbook will be sent through email in 2 to 3 days after the completion of this conference. Finally, we extend our appreciation to each of you for your participation in this online conference. Thank you. Have a nice day. Bye. This is Maheshwari signing off.
Thank you, Maheshwari. We will meet in next conference. Thank you so much.
Thank you, Nora.